So task 2 is going to start talking about these solutions that we just were looking at. So remember, a solution is just the answer that we can plug in to make it true. So a solution of the inequality x is greater than 2 is anything bigger than 2, but it can't include 2 because it doesn't have an equal sign. So x is bigger than 2 could be 3, 4, 5, keep on going. I could go forever. So a solution of an inequality is just the value or values that make the inequality true. It can have many solutions. Like there's no end to the solutions that it could have. If x just has to be bigger than 2, I could go on forever. You can also get all those decimals and fractions in there. I can say 2.5, 2 3/4, 2 3/8. Anything that's bigger than 2 can fit as a solution for our variable. So an inequality such as x is greater than 2 represents something we call a constraint. So a constraint is just a restriction that restricts the values of a quantity or a variable. So x is greater than 2. So yes, there are so many answers that x can be, but there's also a lot of things that x can't be. So the value here says it has to be greater than 2. So I could say that 3 is greater than 2. I could say 4, 5, 6. That's going to go on forever, an infinite amount. However, right, we're restricted to being bigger than 2. X can't be less than 2. So any number that is smaller than 2 or less than 2 is not a solution. So while we do have an infinite amount of things that could be x, we also have an infinite amount of things that are not x. So you've got to list the numbers that make it true. So let's take a look here. So another example is we have x that says is less than or equal to 4. So the values of x must be less than or equal to 4. So in this case, 4 is a solution. 4 is less than or equal to 4. And anything smaller than that is a solution, but anything bigger than that is not a solution. So let's try and make a solution set for x here. So we have x is greater than 2. So we get our little brackets here, these little squiggle brackets to say these are just possibilities. So I want you to see if you can list 3 things that are greater than 2. So 3 things I could plug in for x and have that be true. So pause the video and try that. So let's say I'm picking 7, and you could pick any numbers you want as long as they're bigger than 2. I can pick 39, and I'm going to pick 58. So yes, I could write down 1,500,659, but I just like to keep my numbers pretty simple. So can I put 2 in this solution set? So if I plugged in 2, is 2 greater than 2? No, they're equal, and I don't have an equal sign on here, so I can't use the number 2. I could say 2.001, and that's bigger than 2 because it has this one extra little thousandth piece. It's barely bigger than 2, but it is bigger than 2. I could say 2 and 1, right? 1,000th, same thing here. It just has that one little teeny tiny piece, but it's bigger than 2. So we can't use the number 2 on this one because there's no equal sign, but we can do anything that on the number line is to the right. Let's try this one here. So x is less than or equal to 4. So we want to come up with at least 3 numbers that x can equal that would make that true. So I want you to pause and see if you can write down 3 numbers to make x true. So one thing I want less than 4. So I could say 3 is less than 4. Negative 14 is less than 4. And I can also, on this one, use the number 4. 4 is less than or equal to 4. So because it has this equal sign, I can say, yes, this is true. It's the same or smaller than it. So pay attention when we see those equal signs. You can always include that number in the set. And I always like to include it to remind myself that, yes, it could be equal to this. So we're going to try to make a solution set for this little picture here. So this tells us, right, can you ride this ride? We've all seen these before at the carnivals and things like that. And you have to stand up here. And if you don't hit this line, you don't get to ride. So, right? No. Yes. So let's take a look at their equation. So they said h, their height has to be greater than or equal to 54. So I'm going to ask you some numbers here, and I want you to decide if that's a solution. So I'm going to say 53. So if someone comes up and they are 53 inches, can they ride the ride? No, because 53 is less than that. Okay, what if someone comes up and they are 61 inches? Can they ride the ride? Plug it in. 61 is greater than 54. Yes, they could ride the ride. What if someone is exactly 54 inches? Can they ride this ride? 54 is greater than or equal to 54. 54 is equal to 54. So someone that's exactly 54 can ride the ride. But if someone comes up and they're 53.99 and they're just right below that line, they're not going to get to ride the ride. So it can be equal or it can be bigger. So let's see if we can make a solution set for H here. So we want to come up, that was a very terrible bracket there, but so let's see if we can come up with a solution set and list 3 things that H could equal. So I know H can equal 54 because it has that equal sign. I know that they could be 55 inches. They could be 67 inches. So anything 54 or bigger, because it can be equal, can be listed in this solution. Another one is greater than M. So let's make our solution set. So we want to think of at least 3 things that M could equal. So always ask ourselves, can it equal 1? So this says 1 is less than 1, and that's not true. They would be equal. So it cannot equal 1, or I guess I should say M cannot equal 1 here. So go ahead and see if you can think of 3 things that M could equal that are greater than 1. So I'm going to say it could equal 2. I'm going to say equal 4 and 6. Those are all bigger than 1. 1 is less than 2. 1 is less than 4. 1 is less than 6. So I'm going to graph these here. So here's 2, 4, and 6 would be around there. So I come back to my inequality. So I need to find 1 on my graph. So I make a nice big circle. And this has no equal sign. So right, the garage door is not shut. So I leave it open. That can escape out of there, out of the solution set. And I draw my arrow this direction to include all of my solutions. So M does not equal 1, but it can equal anything bigger than 1. So using that information, go ahead and complete